Hi everyone, this is P.Kameswari from Nalla Narasimha Reddy Education Society Group of Institutions, Integrated Campus, accredited by NAC and MBA. So today we are going to discuss about unconfined compression test. Unconfined compression test. So this is conducted in our Geotechnical Engineering lab. So here this is consists of a dial gauge, mechanical equipment. It consists of a probing ring dial gauge reading. So this indicate the loading and dial gauge reading for noting the values and moving plates, conical seating. So here unconfined compression test means the soil will be unconfined. Soil will be unconfined. There is no mold. So directly the sample soil specimen will be inserted into this in between the conical seating. So moving plate, plowing ring and a handle. So some cases it is attached to the motor also. So what is the procedure? How we can determine the unconfined compression test? So what is the purpose of unconfined compression test? The first, so it is a spatial method. It is a spatial method and which confining pressure is 0. Cell pressure, confining pressure is equal to 0. That means sigma 3 is equal to 0. Confining pressure sigma 3 is equal to 0. It means only deviated stress or shear stress is applied. Since the specimen is laterally unconfined, the test is known as unconfined compression test. So the vertical compression stress is the major principal stress, and the other two principals are 0. Since there is no cell pressure, no rubber membrane required. So therefore, without rubber membrane, sand and dry soils cannot be held in a position. Hence, this test is applied suitable for only clay, saturated clay soils. This cannot be conducted on coarse grained soils such as sand and gravels. Not conducted for sand and gravels. So the axial force at failure P is then sigma D is equal to sigma D deviated stress at failure envelope. Sigma D into F is equal to P by A into F. Sigma A into F. That means axial stress at failure is called unconfined compression strength. Since confining pressure that is equal to sigma 3 is equal to 0. Here major principal stress, minor principal stress. Here one cell pressure and also adjusting. Another two pressures are 0. That is equal to sigma 1 is equal to sigma 3 plus sigma D. One is confining pressure, sigma 1, sigma 3 cell pressure 0. Another one is sigma D deviated stress. So finally here cell pressure sigma 3 is equal to 0. That means sigma 1 is equal to sigma D. Okay. Now that means let QU be the unconfined compression strength. QU unconfined compression strength. QU is equal to sigma 1 confining pressure at failure plane is equal to sigma D into at failure plane F. Generally, you can know the formula. Morse Coulomb failure theory. Sigma 1 is equal to sigma 3 tan square 5 by 2 plus 2c tan 45 plus 5 by 2. That is already discussed in previous videos. Once again, I will show. Here, sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Now, we can take this equation. Sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 pi by 2 plus 2c tan 45 plus 5 by 2. 2c tan 45 plus 5 by 2. Plus 5 by 2. So this is the equation. So here cell pressure sigma 3 is equal to 0. That means this one will be 0. Finally sigma 1 is equal to sigma 1 is equal to 2c tan 45 plus pi by 2. Only 45 plus 5 by 2. Okay. Now 2c tan 45 5 by 2. Here for frictionless soil, for clay soil, for clay, pure clay means pure clay soil, pi is equal to 0. Pi is equal to 0. Pi is equal to 0. Hence 2c tan 45, here pi is equal to 0. 2c tan 45 plus 2c tan 45 plus 5 by 2. So sigma 1 is equal to QU. Here QU is equal to sigma 1. We will substitute here QU is equal to sigma 1. QU is equal to 2c tan 45 plus 5 by 2. That is equal to QU is equal to 2c tan 45 degrees. Now C is equal to QU by 2. C is equal to QU by 2. QU by 2. So shear strength for clays, we know the formula. S is equal to C plus sigma tan phi. S is equal to C plus sigma tan phi. Here phi is equal to 0. That is equal to S is equal to C. C is equal to Q by 2. That means S is equal to Q by QU by 2. Here we will substitute 0. So S is equal to C. In the place of C, we will substitute S is equal to QU by 2. In this case, sigma 3 is equal to 0. That means sigma 1 is equal to sigma D. So there is a unique Mohr circle which pass through the origin. Here one graph will be there. It is used for your problems. Morse Coulomb theory will draw the graph. So radius and diameter and the angle. This angle will be alpha. So here angle, the angle is 45. Draw the graph like this way, and total stress here middle C. So this is the graph. Sigma 1 is equal to QU. This is QU. So here tau is equal to QU by 2. So here phi is equal to 0. Phi is equal to 0. This is failure envelope. FAI, failure envelope. This is the graph. And any advantages. So this test is quick and simple, convenient, and ideally measuring unconsolidated undrained test. And dreammates are the soil which are phi is equal 0. Sandy soil is not required. In such type of soils, we cannot measure this unconfined compression test. Why? Because of phi is equal to 0. Causal less soil, sandy soils, we can't do this test. Only clayey soil. So cannot be conducted on coarse grain soils such as sands and gravels. So this is the unconfined compression test determined in our laboratory.